Welcome to the AI for Career Success video overview by Curt Robbins. We're experts at AI coaching and helping professionals like you and your employees upskill in AI. Today, we're delving into the future of data infrastructure, exploring a significant question. Are we on the verge of moving our data centers into orbit? We'll examine the companies pioneering this technology and the powerful forces driving this potential shift. Our overview today is based on an article by Tim Fernholz titled "The Largest Orbital Compute Cluster is Open for Business," which was published in TechCrunch on April 13, 2026. Now, for all the discussion around space-based data centers, the reality on the ground, or rather in orbit, is actually quite modest. So the central question we need to ask is, what is the strategic and economic rationale for moving our computational infrastructure into space?
Let's start with the current market leader. A Canadian company, Kepler Communications, is really at the forefront here. They're operating the most significant compute cluster currently in orbit and are laying the groundwork for what comes next. So what does this cluster look like? Well, it became operational this past January and is composed of about 40 NVIDIA Orin edge processors. These aren't all in one place. They're distributed across 10 different satellites, all interconnected with laser communication links, which forms a cohesive network in low Earth orbit.
Kepler's strategic positioning is absolutely key to understanding this. According to their CEO, Mina Mitri, their goal isn't to be a data center provider in the traditional sense. Instead, they see themselves as a foundational infrastructure layer, providing network services for other assets already in space. This brings us to a really crucial partnership with a startup named Sophia Space. Their work addresses one of the most fundamental engineering hurdles for expanding computational power in orbit, and that is thermal management. You see, the physics of space present a significant challenge. In a vacuum, dissipating the heat from high-performance processors is incredibly difficult, and the conventional active cooling systems we use on Earth are just too heavy and costly to launch, creating a major bottleneck for scaling up any kind of orbital data center. Sophia's solution is a proprietary technology for passively cooled space computers. By getting rid of the need for active mechanical systems, think fans and pumps, they can manage processor heat far more efficiently. This is critical for reducing both the mass and, of course, the cost of future satellite deployments. To prove their approach, Sophia is partnering with Kepler in a pretty groundbreaking process to de-risk the technology. They're going to upload their operating system to a Kepler satellite and then attempt to configure it across 6 GPUs on 2 separate spacecraft. Now, this is the first time anyone has tried a multi-GPU software configuration in orbit. It's a vital step before their planned satellite launch in 2027. So, what's driving all this investment from a business perspective? Well, the immediate value isn't in building massive general-purpose data centers. Instead, it lies in a very specific application: edge processing. Edge processing simply means analyzing data right at its source. For space applications, this means processing information from sensors directly in orbit, rather than sending it all back down to Earth. The key benefits here are a massive reduction in latency and a much lower volume of data that needs to be transmitted. The initial customers for this kind of capability include private companies and various government agencies. A really significant driver is the U.S. military, which requires this technology for its next-generation missile defense systems. Also, power-hungry sensors, like those used for synthetic aperture radar, benefit greatly from offloading their processing tasks while still in orbit. This focus on edge processing really reveals 2 distinct strategic visions emerging in the market. You have the Kepler and Sophia model, which uses distributed GPUs optimized for inference tasks, that is, making real-time decisions based on incoming data. This allows for continuous 100% utilization. In contrast, you have larger players focused on superpower GPUs designed for training AI models, which is a far more power-intensive and intermittent type of workload. So let's zoom out to the long-term vision and see how this all builds. These initial steps in orbital computing are truly laying the foundation for a future where a significant portion of our data infrastructure could reside beyond Earth's atmosphere. This timeline kind of illustrates the progression. Right now, we're in the era of these specialized edge processing clusters. By late 2027, we anticipate Sophia's first dedicated hardware launch. And looking further ahead, industry experts are projecting that large-scale general-purpose data centers could actually become a reality sometime in the 2030s. Now, interestingly, a significant driver for this shift might not come from the pull of space, but from constraints right here on Earth.
The immense power and water consumption of terrestrial data centers is leading some municipalities and even governments to consider moratoriums on any new construction.
As Sophia CEO Rob DeMillo noted in response to a Wisconsin city banning new data center construction, this pressure on Earth creates a powerful incentive to develop space-based alternatives. His comment, "It's going to get weird from here," really underscores the potentially disruptive shift that's on the horizon.
So the crucial point we're left with is this. While the technological pull of space is undeniable, could it be that the resource limitations here on Earth are becoming the most powerful force pushing our critical digital infrastructure into orbit?
Thank you for watching. This is where we teach you AI and help you get smarter than your competition. If you like these videos, please use the QR code you saw at the beginning of this video to buy us a coffee. Or you can hire us to coach you or your employees in AI. To stay ahead with AI for career success, we'd appreciate it if you'd subscribe to our YouTube channel. And please, like this video, comment with your thoughts, and share it with your network to help us reach a wider professional audience.